Welcome, ladies and gentlemen, to the group exhibit Hydrogen Fuel Cells and Batteries, here to our public forum. Our questions are decentralized, lower cost, fit to size and demand, modular, expandable. Is that possible? And so far I can tell you it is, but we have to prove it. So I'm very happy to have here on stage with us in our mid, it's Sable Huang, she is president. Right next to me, Florian von Hofen, he is CEO of Rouge Hydrogen Engineering GmbH. And opposite of me is Viktor Hacke, Professor Dr. Viktor Hacke, is consultant of Rouge Hydrogen Engineering, and himself he is head of Fuel Cell Group, Graz University of Technology, Institute of Chemical Engineering and Environmental Technology. Welcome all here on stage, and you may participate whenever you want. If you have a question, just raise your hand, there will be the microphone right with you. Well, Mr. von Hofen, I know Rouge Hydrogen is a new company. It's situated in Graz, a beautiful city of Graz, in the Steiermark, in Styria, and has an automobile cluster with big companies like AVL and Magna called AC Styria. You are part of it. Your hydrogen, your hydrogen is meant for fuel cell cars and buses. That's the idea behind it?
That is one of the ideas. It's for fuel cell.
We still can't hear you. Oh, sorry.
Well.
We still need some...
no problem.
Michael, we need some power here. Okay,
Okay, so that's probably better. Yeah, sorry. Of course, it's made for cars and buses as well, but for any other application where you need pure hydrogen as well. So that can be in the food industry, in glass industry and so on. But our original reason why we went to Graz is indeed the very good infrastructure there on the university side as well as on the engineering side. And as you said, it's a beautiful city, so it's very nice to work there. But our solution actually is, of course, mainly for the mobility, but also for other applications, wherever you need decentralized solutions.
It's not only a beautiful city, it's also a smart city, Mr. Huang. I have just been to Helmut List Hall. In this area, they're really building up a smart city, and probably hydrogen will play an important part in it.
Yes. When we talk about hydrogen society, our vision is that every smart city can produce hydrogen on site from biogas, and to boost local economy and improve air quality.
Very good. Yeah, but that would be indeed very smart, Mr. Hacke. You also have some issues with clean air in Graz, of course. You're struggling very hard to reach that. But as far as I see here on the group exhibit and in the community of fuel cells and hydrogen, everybody's talking about 100% renewable. It has to be, but that's not normal. It's not the case. The most hydrogen we have is made by steam reforming, isn't it?
Yeah, I think hydrogen is already available, not for energy purposes, but for many other purposes. It is available, and it's basically made of natural gas, of coal and other fossil fuels. But of course, this technology, which was developed has been developed for more than 10 years at TU Graz, should open a door for clean hydrogen production, also based on renewables like biogas.
So you brought with you, Herr von Hofen, this reactor, everybody can see there, and it's not an electrolyzer, we can tell so far. It's a steam reformer, actually, but it's a special steam reformer. Please tell us a little bit about it.
Yeah, I mean, we have not really reinvented the wheel, and first of all, to say it clear, it's not an electrolyzer. It's a reformer, and the special thing about it is that the entire steps that we are talking about are in one system or in one unit. That means we have a feedstock inlet here for any kind of gaseous feedstock, no matter whether it's biogas, whether it's natural gas, whether it's probably even coal bed gas. Then we have a part which is kind of a cartridge where we decide on which the right cartridge for the right feedstock. It contains a catalyst which is working with the feedstock, and then inside the unit we create a syngas which then reacts with the metal, so we can store the hydrogen then that we have just produced right in the unit with the metal. And we have a special metal granulate which is, let's say, a special composition, but very cheap and easily to get. And at the end of the day, when we need the hydrogen, we can release it by just putting in some hot steam, and then we can release at a relatively high pressure. Standard is up to 40 bar, but we have even reached 100 bar already. So the interesting thing is all of it, producing, storing, releasing, is in one unit.
Professor Hacker, metal hydrate storage I haven't heard of for a long time actually, but it's coming again. You know, it's getting better and better, isn't it?
But it's not metal hydride.
Okay, so
it's
tell
not
me.
metal hydride. So maybe this has now a little bit of misunderstanding because it's a unique process. So sorry, it's a unique process. I mean, at the end you have a contact mass, you charge and discharge. You don't have a metal hydride. You have a contact mass like iron-based contact mass, which is reacting itself. So you charge it with a biogas or a hydrocarbon. Then you have it stored, and whenever you need it, you put steam into it, and you produce hydrogen. Steam is then split into hydrogen and oxygen, and the oxygen is reacting with the contact mass and is oxidizing the contact mass. So you have a system which is not metal hydride and which has several advantages. I mean, the first advantage is you are quite flexible. Like Florian said before, you can change the hydrocarbon quite easily. The second thing is you produce in one step pure hydrogen, high purity of hydrogen. And in addition, it's possible under pressure. And it's possible with a two-step pressure. That means charging at ambient pressure, discharging at high pressure. This is what you need. So you get pure hydrogen at high pressure. And you charge with biogas at ambient pressure. This is also quite a unique feature of this process. And yeah, it is not metal hydride, it's a contact mass, which is, not many groups are working on this.
But does it really make sense to have it in the same device, or should you separate it? What was the reason that you put it in one device?
One device means now what? The reformer?
It's the one pipe, you know, the reformer is in it.
Yeah, but it's the big advantage. I mean, you have a similar temperature range. You have a similar temperature range, and you don't. I mean, a challenge of hydrogen production is on the small scale. On the big scale, you have hydrogen. On the small scale, you have the problem you can't get reasonably cheap hydrogen purification systems. So you don't get. And this is included here. It's quite a simple system with a high purity hydrogen product. So it should show that it's not complex.
So, Mr. von Hofen, you at least need two of them probably, because you can't do both at the same time, can you?
That's correct. 2 is the minimum, but then, of course, we can expand to any size of the system.
And it's expandable, of course.
Yeah, expand and use several, for instance, 50 of them in parallel. 50, for instance, just to give you an idea, would make a perfect solution for a refilling station for about 50 to 80 cars a day, 250 kilogram production. And we use one standardized module and then just increase the amount of them according to the demand of the customer. So you can also, if you say I have only 5 hydrogen cars in my city, you can start with a very small amount and then expand later on when also the number of buses or cars in your city or your community expands.
How many buses or cars who run on hydrogen do you have in Graz? Not one yet, have you?
I'm not the mayor of Graz, but I have to defend. I have to defend Mr. Nagel a little. I mean, he's doing his best and working very hard on making Graz really a green and smart city. We really have to appreciate that.
The smart idea about smart cities and about this reformer is that it's modular and you can install it in any refueling station. You don't have to install a big electrolyzer, which is not so modular as your device. You can just start with, let's say, 10 of these pipes and then build up until, well, let's say 100.
That's exactly the idea. Because this is, of course, a part of the famous chicken and egg discussion, you know. And instead of bringing hydrogen on big trucks with a lot of emission to the stations, we can produce the hydrogen on site This is why we call our system an on-site, on-demand system. And we believe that this is a really big step to make it easier to get hydrogen at any place where you need it and to make it affordable.
So for the first Toyota Mirai, how many of these gas reforming pipes do you need?
For just one?
Just one, yeah.
Just two of them.
Just two
That's
of them
no problem.
would be enough.
Yeah.
So how much does it produce per day?
One pipe like this, which is actually not the original size. We shrinked it a little bit for the show here. The real one is about 30% bigger. We can produce almost 5 kilogram a day.
Almost 5 kilogram, and how much can you store in it?
Yeah, we can permanently store a little less, which is about 1.2, 1.4 kilogram. So if you want to use it as a permanent storage, you probably have to have other parts. But you know that in a system of a petrol station or a refilling station, then you have other parts where you have the compressed storage and so on, which will be delivered by colleagues, which you find here in the hall. So we do not need a 5 kilogram storage for a 5 kilogram production.
So, Professor, what kind of gas can I use for it? Probably natural gas, I guess that's possible. But could I also use biogas or any other kind of gas?
Yeah. Yes, basically yes. As Florian said already, you have to adjust the reformer. The reformer is here a commercial unit. You start with a reforming process. We have operated it with biogas and with natural gas. We are going to operate it with liquid fuels as well, that we reform liquid fuels like ethanol. But basically this is possible with commercial available reformers. And then the synthesis gas is directly fed into the contact mass. So you are quite flexible.
Even coal bed gas could work. You think so? Okay.
You don't need to reform. Yes, you can use it directly.
Yeah.
I mean, it depends maybe on the impurities, but this is then you have to see when you go to the application. Yeah.
Mr. von Hofen, part of your application is an user-friendly software to run this reformer. How do you think about that? Is it software which you install on site, or will you control it remotely?
Well, of course, you have to understand this is what we call hardware. That's
hardware,
more or less it's metal.
Yeah.
And this is not everything. So there's a lot of knowledge, a lot of sensors and other things and software that you have to use. And as Mrs. Huang said, we are kind of devoted to the idea of the smart city, which also means Internet of Things, which means Industry 4.0, networking, and so on and so on. And that means that, of course, in our software development, you can control, supervise, and even emergency stop or whatever should ever be necessary, these things from a different place, remote control. So we want to make sure that the person which is working with this on site, for instance in a filling station, does not need a special qualification. Anybody can do that. And the, let's say, more classy works like when is the next maintenance and all these things are done remotely from another place.
That's intelligent, and that's how it should go. The digital part of the product is often not really on focus, but you have it from the very beginning in the focus, which is very good, I think. So are there any questions from your side? Just raise your hand if anybody has a question. Come with the microphone right to you. So let's summarize. Once again, is it decentralized, Mr. von Hofen?
That definitely is. I mean, that is the big part of the concept is that we do not go the way of a big refinery and then a lot of transportation through the country, which in small countries is easier than in big countries. We should sometimes not only focus on our own country like Austria or Germany, but if you go to other countries abroad, it's really long distances that have to be driven from the refinery, for instance, to a filling station. So this is something, if, for example, you have a country that has already 300 stations that deliver gas to gas-driven cars in a very short amount of time and with almost no infrastructure work, we can switch these only gas stations into gas and hydrogen stations. So that is the decentralized idea, that wherever you have one of the feedstock gases that we need, you can create hydrogen, and you can create small amounts or you can create big amounts just depending on what you decide.
Osaka, and can we produce hydrogen at lower costs?
Yes, we will be able to do it, because the main advantage is we don't have expensive materials in it. Of course, we at the university are still in the developing phase. So, but we don't use any expensive noble metal. We only use a commercial reformer
Like you
catalyst.
need in electrolyzers like platinum and iridium. You don't need it
Yes,
at all. in there.
or you need also in gas cleanup, like membranes, you still use noble metals, so you cannot get rid of them, and here we don't use them.
All right. So is it fit to size and demand for Van Hofen?
I think it should be, because every customer has the choice what he wants and what he needs, and also what he wants and needs at this particular moment. That means if he starts with a small amount, it's fine. If he wants to increase the amount that he needs, we can deliver that in a very short amount of time. So he does not need to buy something oversized from the very, very beginning. I think that's a big help.
And it's obviously modular, Professor Hacker, because we see just one model.
Obviously modular.
So it's obviously modular. You can size it up as big as you need it. And it's expandable as well. We've talked about that, Van Hofen. So we have answered all these questions, which were our topic today. Would like to thank you very much. If there are any more questions, just feel free to visit Rouge Hydrogen Engineering just over there. It's just a few steps in that direction, and ask them more questions. I would like to thank you very much for our talk here on stage, and I would like to thank you very much for your attention. Thank you.
Thank you.
Thank you.